Now let's start with the next topic of the matrix is a transpose of a matrix. Transpose now the transpose of the matrix. Now the meaning of the transpose is the now let's see the meaning of the transpose is changing its row into columns and its column into rows. Meaning of the transpose is changing its rows into columns and its columns into rows. So how to write the transpose? Now let's see. The A is a matrix. A matrix is Aij. Order of this is m by n. Now the transpose of the matrix is denoted by this or A dash. Transpose of this matrix is denoted by the A transpose or the A dash. Both are represent to the transpose of matrix. Now the if we find the transpose of this matrix means now that A transpose matrix is A J I. Now for all I equals to 1, 2, 3 up to m and j 1, 2, 3 up to n. Now let's take the example. Now if a equals to 5, 4, 2, minus 1, 6, 7, 3, 1, 9. Now if we find the transpose of this matrix, so transpose of this matrix is now converted the row into columns. So this row is 5, 4 and 2. So write 5, 4, 2, then minus 1, 6, 7, 3, 1, 9. So it is a transpose of matrix A. So next example which is based on this. Now if A equals to 1, 2, 3, 4, 2, 3, 4, 1, 3, 2, 1, 4. So now write down the rows into column form. So the A transpose of this 1, 2, 3, 4, 2, 3, 4, 1, 3, 2, 1, 4. Now let's discuss with the properties of transpose. Now the first property is for any matrix A, if we first of all if we find the transpose of the matrix A, then again if we find the transpose of this matrix is equal to the transpose. So transpose of the transpose matrix is, so let's proof of this. Let A matrix is Aij m by n matrix. So now the transpose of the A matrix is, transpose of this matrix is, now here the order of the matrix A is m by n. So now in the transpose of the matrix, now the order is Now A transpose is n by m matrix. So now if we again find the transpose of the transpose matrix, so now the again the order of this matrix is m by n. So the A transpose of the transpose, now again the order of this matrix is m by n. So the A transpose of the transpose, now the transpose matrix of the transpose is A. मीन्स अगर हम किसी मैट्रिक्स का ट्रांसपोज लेते हैं, उसके बाद अगर दोबारा उस ट्रांसपोज मैट्रिक्स का ट्रांसपोज मैट्रिक्स फाइंड किया जाए तो वो वापस किसके इक्वल हो जाएगा, ए के. नाउ द सेकेंड प्रॉपर्टी, फॉर एनी टू मैट्रिसेस A and B of the same order, then A plus B whole transpose is equals to the A transpose plus B transpose. Now if first of all we add the two matrix, then find the transpose, now which is equals to the, firstly individually find out the transpose of the matrix. Now the transpose of the matrix A is A transpose. Now the transpose of the matrix is B T. So now the A plus B whole transpose is equals to the A transpose plus B transpose. Now let's see the proof. Now A plus B whole transpose is Aij, means A plus B after the transposing, now the rows is converted into columns, so it is AB Ji. Now the AB transpose, now AB transpose Ij equals to Aji plus Bji. Now the Aji is the A transpose of Ij, or it's a B transpose of Ij. So the A plus B whole transpose, so A plus B whole transpose is equals to the A transpose plus B transpose. Now the next property is, if A is a matrix, if A is a matrix and K is a scalar, then Ka whole transpose is equal to Ka transpose. Now the next property, if A and B are two matrices, if A and B are two matrices such that AB is defined, then AB whole transpose is equals to B transpose A transpose. Now let's see proof of this. Now the proof. Now A and B are the two matrices. Now the multiplication of the two matrices is possible when the number of columns of the first matrix is equal to the number of columns of the first matrix is equal to the number of columns second matrix. Now let's see, if A matrix is Aij order of this matrix is m by n, and the B matrix is Bij, order of this matrix is n by p. Now if we multiply the AB, then the resultant matrix order is m by p, then the resultant matrix order is m by p. So if we take the AB whole transpose, then the transpose matrix order is P by M. Since now A transpose and B transpose are, now the A transpose order is N by M, and the individually the B transpose order is P by N. So now in these two matrix multiplication is possible when the B transpose is multiplied with the A transpose. When the B transpose is multiplied with the A transpose. If we multiply the A transpose with the B transpose is not possible because M is not equal to P. But in the second matrix, number of columns is equal to the first matrix number of rows. So the multiplication of the B transpose into A transpose is possible. So if we multiply the B transpose with the A transpose, then the resultant order matrix is P by M. So it is proved. So AB whole transpose is equal to the B transpose A transpose. Now generalization in the, now it's a, now this property is only for the two matrices. Now if we take the three matrices for the product, then A, B, C, if we multiply, then we take the transpose. If we take the transpose of this matrix now is equal to the C transpose B transpose A transpose. Now let's take this some example which is based on the transpose matrix. Now let's take the example. Now this question is asked in the CBSE 2002 and again asked in the CBSE 2005. Now if A equals to -1, 2, 3, if and B equals to -2, -1, -4, verify that AB whole transpose is equals to the B transpose A transpose. Now let's see in the solution. A equals to -1, 2, 3 and B equals to -2, oh sorry, for here it's not a comma. Now -2, -1 and -4. Now first of all multiply the matrix A into B. Now the order of this matrix, is 3 by 1. Now the order of this matrix is 1 by 3. So the resultant matrix order is 3 by 3. So resultant matrix order is 3 by 3. So if we multiply the A into B, then -1, 2, 3 is multiplied with -2, -1, -4. So we get, now the -1 is multiplied with the -2, so it is 2, -1 is multiplied with the -1, then it is 1, then it is 4. When the 2 is multiplied with the -2, so it is -4. It is 2 is multiplied with -1, then -2, 2 multiplied with -4, so it is -8. Now again the third row is multiplied. So 3 is multiplied with the -2, it is -6. 3 is multiplied with the -1 is -3. 3 into -4, it is -12. So if we take the transpose of this matrix, so AB whole transpose is 2, -4, -6, -1, -2, -3, 8, sorry, 4, -8, -12. Now it is a transpose. It is a AB transpose. Now if first of all we find the B transpose, then we multiply with the A transpose. So B transpose is minus 2, minus 1, minus 4, or A transpose is minus 1, 2 and 3. So B transpose into A transpose, minus 2, minus 1, minus 4, minus 1, 2 and 3. Now if we solve this, then we get 2, minus 4, minus 6, 1, minus 2, minus 3, 4, 8 and minus 12. So now it is proved the AB whole transpose is equal to the B transpose into A transpose. Now let's take the next example. Find the values of x, y, z if the matrix A, if the matrix A, now the matrix A is given the 0, x, x, 2y, y, minus y, z, minus z and z. Satisfy the equation, satisfy the equation A transpose into A equal to identity matrix of the 3 by 3. Now let's see in the solution. Now first of all, find the transpose of the matrix A is 0, 2y, z, x, y minus z, x minus y and z. Now it is the transpose of the matrix A. Now the A transpose is multiplied with A. So 0, 2y, z, x, y minus z, x minus y. Now the A is multiplied. So 0, x, x, 2y, y minus y, z minus z, z. Now it is given equal to the identity matrix. So now first of all multiply the A transpose into A. So if we multiply the A transpose to A transpose, so we get the 2x square 0, 0, 0, 6y square 0, 0, 0, 3z square. Now after the multiplication we get the A transpose into A is 2x square 0, 0, 0, 6y square 0, 0, 0, 3z square. So now if we compare the A transpose into A with the identity matrix, so 2x square 0, 0, 0, 6y square 0, 0, 0, 3z square, compare with the identity matrix, so 1, 0, 0, 0, 1, 0, 0, 0, 1. So now the 2x square equals to 1. So x equals to plus minus 1 by root 2. 6y square equals to 1. So y equals to plus minus 1 upon under root 6. Now the 3z square equals to 1. So z equals to plus minus 1 by root 3. Now let's take the example. Let's take the next example is if A transpose is equal to 3, 4, minus 1, 2, 0, 1. B is equals to minus 1, 2, 1, 1, 2, 3. Find A transpose minus B transpose. Find A transpose minus B transpose. Now the A transpose is given in the question. So find first of all the B transpose. So B transpose is minus 1, 2, 1, 1, 2, 3. Now the A transpose minus B transpose. So it is 3, 4, minus 1, 2, 0, 1. And the B transpose is minus 1, 1, 2, 2, 1, 3. Now if we subtract the two matrix, then we get 3 and the minus of minus 1 is 4, 4 minus 1 is 3, minus 2 is minus 3, 2 minus 2 is 0, 0 minus 1 is minus 1, 1 minus 3 is minus 2. Now let's take the next example. If A equals to cos alpha, sin alpha, minus sin alpha, cos alpha, then verify that A transpose into A is the identity matrix of 2 by 2. Now let's the solution. Now the A transpose is cos alpha minus sin alpha, cos alpha. Now the A transpose is multiply with A. So cos alpha sin alpha minus sin alpha cos alpha, cos alpha minus sin alpha cos alpha. Now the first row is multiplied with the first column. First row is multiplied with the first column. So cos alpha into cos alpha is cos square alpha, and the sin alpha into sin square alpha. Sin alpha into sin alpha is sin square alpha. So cos square alpha plus sin square alpha is 1. Now cos alpha into minus sin alpha into cos alpha, it is 0, minus sin alpha cos alpha sin alpha, it is 0. Now minus sin alpha is plus sin square alpha, cos alpha into cos alpha, cos square alpha. So sin square alpha plus cos square alpha is 1. Now it is equals to the identity matrix of 2. Now in the next lecture we will discuss about the symmetric and the skew symmetric. Now this topic is the last topic of the matrix.